everyone, welcome to my YouTube channel. I am again in front of you with the lecture of class 12th. In the lecture of class 12th, today I will solve some question of exercise 5.1. Okay, this exercise is of continuity. In this we have to show that the function is continuous or not, or we can find the point of discontinuity by using the same definition which I have told to you in my previous lecture. Okay, so let's start with the question number 7, in which you have to find all the point of discontinuity of f that is defined by this. In this function there are two numbers which are given here. One is -3 and the second one is 3. So we have to check the function for two values. First is x is equals to -3 and the second one is x is equals to 3. So let's start with the x is equals to the function's value at x is equals to -3. Okay, and when you want to solve it, you have to write it at x is equals to -3. Take left hand limits. Left hand limit x approaches to -3 negative fx. What is the value of -3 less than, that is less than negative -3 negative, that is less than value. Take mod x, limit x approaches to -3 mod x plus 3. Now I will write the value for negative value, the modulus will be negative. The limit x approaches to negative minus x plus 3. But for eliminating this negative left hand limit and right hand limit, this negative and positive sign, I will use h approaches to 0. When I use h approaches to 0, I will change x into -3 minus h plus 3. Okay, now put the value of h, that is 0. That means 3 plus 3, that is equals to 6. Minus plus, it will come 0 and the 3 plus 3 is equals to 6. Now come to the right hand limits. Right hand limit, at right hand limit, I will take limit x approaches to -3 plus. -3 plus, that means it's a sign of right hand limits. Fx, what is the right hand limits function? That is -3 positive. This is a function at -3, minus x is greater than -3, that is -2x. So I will write -2x. Now I will change it by h approaches to 0. In the right hand limit, the value of x will change as -3 plus h. Put the value of h, that is 0, -2 -3 plus 0, that is 3 2s are 6. In this value, in this term, we have also -3. I will take -3 plus 0 plus 3. That means minus plus 3, that is equals to 6. This is also minus plus 3 2s are 6. Now I will put the value at f of -3 in the direct function, not using limits. Only directly you have to take the value of equality, that is mod of -3 plus 3. Mod will change, it is absolute value, 3 plus 3, that is 6. This implies left hand limit equals to right hand limit equals to f of -3. That means this implies f is continuous at x is equals to -3. Now this is the first part on which you have to check. The second part is you have to check the function for 3. So this is the second part. There is a less than and greater than, both limits are given. So you have to check for x is equals to 3. How we can check? I will take it as 3. Similarly, left and right, both values will use. Okay, so I will start it with the x is equals to -3. So how you can put the values, not -3, it is 3. So how you can take the value? It is at 3. At 3, when you use limit x approaches to 3 negative fx, what is the value of less than 3? That is -2x. Limit x approaches to 3 negative, that is -2x. To eliminate this negative and positive sign, I will use h. H is a very little value. I have told to you in my previous lecture that this is a little bit value in the neighborhood of x. So that is limit h approaches to 0. When I put the value, x will change into 3 minus h. Now take 0. H as a 0, this is minus 6. Now come to the right hand limit. Limit x approaches to 3 positive. After solving this left hand limit, I will solve the right hand limit. This is 3 positive. For 3 positive, I will take 6. Limit x approaches to 3 positive. 6 plus 2. Right? To eliminate this one, I will again take h approaches to 0. When h approaches to 0, I will take the value of x, that is 3 plus h. Okay, so I will convert the values into the form of h. 3 plus h plus 2. That is, when you put the value 0 here, 6, 3 plus 0 plus 2, that is 18, 19, 20. No need to do the third step because left hand limit is not equals to right hand limit. This implies left hand limit not equals to right hand limit. This implies f is not continuous at x is equals to 3. That means point of discontinuity, that is continuity is 3. So this is the point of discontinuity. On first numbers, the function is continuous at minus 3, but function is not continuous at 3. So the point of discontinuity is 3. Now come to the next question. The next question is also in the form of mod. Okay, I will take the questions for modulus, that is of modulus sign. So how you can use it? I will apply the definition of modulus. What is that value? Modulus function for less than value it will be negative. For more than value it will be positive. Okay, so let's start with the question. Question is fx, that is question number 8. In the question number 8, fx is given as mod of x upon x when x not equals to 0 and 0 when x is equals to 0. Okay, so how you can solve this question? This question is very simple. You have to take the definition of modulus of x for left hand limit and right hand limit. For left hand limit, you have to take it as a negative x. As I will use here left hand limit, that is limit x approaches to 0 negative fx. Limit x approaches to 0 negative mod x upon x. This modulus of x 0 negative, that will convert it into negative for less than cases. So this and this will cancel, we get minus 1. Okay. For right hand limit, when we apply the right hand limit, limit x approaches to 0 positive fx. What is the value of that function f of x 0 plus mod x upon x? For the positive value, I will take the value of modulus x is equals to x. Okay, limit x approaches to 0 positive x upon x. This will cancel, we get 1. This is the value of left hand limit. This is the value of right hand limit. Both are not equal. That means f is discontinuous at x is equals to 0. This implies left hand limit not equals to right hand limit. This means x is discontinuous at x is equals to 0. That means point of discontinuity. That is, this is a short form of discontinuity and this is discontinuous. Point of discontinuity is 0. Okay, so you have to take the solution like this to find the point of discontinuity. Now come to the one more question. That is question number 9. Question number 9 is same as this question. In question number 9, there is x upon modulus of x. So do you have to do the question number 9 same in this manner? Okay, so I will do the question number 10 for you. That is different from this question. So I will take the solution 10th. Okay. So I will start the quick solution 10th. In 10th solution, we have two values for less than limit and greater than limit. The one first is x. Question number 10. Fx is defined as, we have two values. First is x plus 1. When x is greater than equals to 1, then x square plus 1 when x is less than 1. So we have to check the point of discontinuity for this. So we have to check by taking left hand limit. Okay, when you take it as left hand limit x approaches to 1 negative. For 1 negative you have to take this function, because for less than, limit x approaches to 1 negative x square plus 1. Limit x approaches to change this 1 negative and 1 positive, we will take h approaches to 0. I will change x by using 1 minus h whole square. The value of x depend on 1, 0, which the number which is present here, 1 minus, and if there is a positive, the 1 positive h. Here we have 1 negative, the 1 negative h whole square plus 1. Now put the value of 0, that is 1 plus 1 is equals to 2. When you put the value 0, I will write that step so that you should not be confused. 1 minus 0 plus 1, that is 1 plus 1 equals to 2. So this is the left hand limit. Now come to the right hand limit. How you can solve? Take the limit x approaches to 1 positive. For 1 positive, you have to take the value of greater function, that is here x plus 1. Limit x approaches to 1 positive, x plus 1 for the greater value. So x plus 1. But I will change this by using h. In this place, the h will change into 1 plus h plus 1. Put the value 0 here, 1 plus 0 plus 1. That will equals to 2. Now the third step, when the two steps are equal, we will take the third step. What is that step? You have to put the direct value, that is f of 1. That is, you have to take the equality value, that is 1 plus 1, that will equals to 2. This means left hand limit equals to right hand limit equals to f of 1. That is point of discontinuity. That is discontinuity is x is equals to 1. So this is the point of discontinuity. The function, this is not no point of discontinuity, because these three are equal. The f is continuous, not discontinuous. F is continuous at x is equals to. Why there is no point of discontinuity? Because all the three functions are equal. F is continuous at x is equals to 1. There is no point of discontinuity. No point of discontinuity. Okay. Discontinuity, because the function is continuous. Therefore, there is no point of discontinuity. Okay. So this is the way to solve the points for discontinuity. Now I will do the one question, different question for all of you. What is that question? In that question we should not be we will not find the value for the continuity or discontinuity. We will find the relation. What is that question? We have to find the relation. What is that question? The question number 17. The 17th question is different. 17th question is find a relation between A and B. Find a relation between A and B. Between A and B. A and B. If so that the function fx is equals to ax plus 1 when x is less than equals to 3, and bx plus 3 if x is greater than 3 is continuous at x is equals to 3. So this is the question in which you have that function is given as continuous at x is equals to 3 and you have to find the relation only. How you can find the relation? By using the solution. F is continuous at x is equals to 3. This means left hand limit equals to right hand limit equals to f of 3, right? Take the left hand limit. Limit x approaches to 3 negative fx is equals to limit x approaches to 3 positive fx is equals to f of 3. So I will put the values of these three terms. Limit x approaches to 3 negative. 3 less than, for less than value we have ax plus 1. Limit x approaches to 3 positive, we have bx plus 3, and for equality we have this value, that is in place of x we will put 3a plus 1. Okay, when you take the value of limit h approaches to 0, this will change into 3 minus h plus 1. Okay, when you use here h approaches to 0, this will convert into 3 plus h plus 3 is equals to 3a plus 1. When you substitute the value 0 here, it becomes 3a plus 1. When you put the value 0 here, that is 3b plus 3 is equals to 3a plus 1. We need only two values to find the relation. We need only these two values. So how you can find 2a plus 1 is equals to, I will take 3 common. When you take 3 common, it becomes b plus 1. Okay, I will take this 3 in the denominator, 3a plus 1, that is equals to, upon 3 is equals to b plus 1. Okay, you can take the LCM or you can take the subtraction sign here, 3a plus, either you can take a and b together. This is if you want to take the values together like this, 3a is plus 1 equals to 3b plus 3, it will equals to 3a minus 3b is equals to 3 minus 1, that is 2. Take 3 as a common factor, a minus b. So a minus b is equals to 2 by 3, or you can write it as 2 by 3 plus b. This is the relationship between a and b. This is the way to find the relation between a and b by using the definition. Okay, do the practice of these type of questions, do the point of discontinuity and do the relationship. Other question of relationship. Thank you.